All right, so as we're getting ready for our test tomorrow, I put together, actually, these are 5 problems from a previous year's test that were kind of the 5 most missed questions from that test. Test hasn't changed too much. Obviously, we changed like numbers and examples and stuff like that. But to be honest, these are kind of the key ones that people have made errors with in the past. So simplifying, and this is just a subtraction problem. And these actually aren't super difficult, but the thing that students tend to make errors with if they do on these is just dealing with this negative. Because when you're subtracting a quantity like this negative needs to go to every one of these 4 terms. I always think you're less likely to make mistakes if you just write it out. So this negative is going to change this to a negative. It's going to change this to a negative. It's going to change this to a positive, and it's going to change this to a negative. And then these parentheses really don't even need to be here, because at this point, now we're going to combine these 4 with these 4, see if there's any like terms, and get it all written out in standard form. So let's do that. So we've got a 2x to the third minus a 7x to the third, which is going to be a minus 5x to the third. That's going to be my lead term. And I'm just going to kind of cross them off as I go, just to make sure that I'm not missing anything. 9x squared minus a 9x squared completely cancel each other out. Those are opposites, so you won't have an x squared term in this problem. X plus a 4x makes a 5x, because remember, 1x, 4x makes 5x. And then negative 12 minus 8 makes a minus 20. And that's it. Nothing crazy, nothing super complicated. But again, the most common errors are, number 1 is this distributing the negative, making sure you do that. And then just being really careful when you're adding your coefficients. When you do your coefficients together, remember, it's not going to change the variable at all when you're adding and subtracting. All right, so that's the first one. Again, one you definitely should get right. Number 2 here is a multiplication problem. Again, this is what I would call pretty much a must-have skill moving on from Algebra 2. And so in this case, this is going to be your distributive property. And since you have 2 terms times 3 terms, you're going to get 6 total terms. Then you got to look and see if any of them combine. So we just get into it. So now we're multiplying. This is where we are going to increase our powers. So when you multiply 2 terms, you add their powers. So we'll get x to the 5th. Right here, we'll get a minus 5x to the 3rd. And right here, we'll get a minus 3x squared. All right, so that term's been exhausted. Now we move on to the minus 5. So we're going to get minus 5x to the 4th. We're going to get plus 25x squared. And we're going to get plus 15x. Okay, perfect. At this point, we get it to standard form, we combine any like terms, and we'll be all set. So highest power is this x to the 5th. There's just the one. The next is this x to the 4th, and there's no other one, so I'll just write it down here. X to the 3rd, also only one of those. And then we do have a minus 3x squared and a plus 25x squared. Those two are like terms, so those combine to be 22x squared. And lastly, the plus 15x. Okay, looking good. If you're doing one of these and you want to check that it's right, and see what even hold for the previous problem too, if you ever want to just check if these 2 things are equivalent, you can type them in. So I'll type in my calculator to show you what I'm talking about. All right, so what I was talking about with this is, if I took my original problem, the original expression here, typed in with the parentheses, I took what I thought it came out to be and I typed it out here. Obviously, it does take a minute. You got to be careful typing it in. If you're using the calculator, I usually don't really use the graph, because the graph, it's hard to tell if it overlaps or not. On the calculator, I'll use the table. And I'll just check the tables are identical. In our case, they are. If you're using decimals and you're graphing them, then you'll be able to see it'll overlap the 2 graphs, and it's going to be pretty clear on there. But again, just an easy way to check and see if you're right. And you can do that exact same thing on this first problem too. If you wanted to type this whole thing in and then type this in as a separate equation, they should be equivalent. Okay, so it's an easy check for those types of problems. Okay, number 3 says graph this and identify the intervals where it is doing each of these things: increasing, decreasing, positive, negative, etc. So I'm going to go ahead and just go right to graphing this. I'm going to use the calculator, and we'll see what we've got. So if I graph this guy, we've got, this style of graph. It's got obviously parts where it's negative, positive, negative, positive. It's got parts where it increases, decreases, increases. And so we just need to write those intervals. Even though it's written in this order, my mind always likes to do positive and negative first, so that's what I'm going to do. So this graph is negative here and here. And I believe these zeros are at whole numbers. Yeah, so they're at -2, 0, and 3. So -2, 0, and 3. Actually, let's do this. I'm gonna just make a little sketch of this from here so we can kind of draw on and point on things as we're working. So this one's at 3, this one's at 2, and this is obviously at 0. Okay. So the positive intervals are going to be this part, so from -2 to 0, and also this part, so from 3 to infinity. Okay. Negative intervals are the start of the graph, so -infinity to -2, and this little part here, so from 0 to 3. All right, so that's a skill we've been doing for a long time now. I think we started doing intervals back in like week 2 of this whole class, and they just kind of come up in basically every function we look at. And then lastly, for increasing and decreasing, you do need to know these coordinates. Now, I'm pretty sure this one's going to be at -1, and I'm pretty sure this is going to be at 1.5, but we should double check it just to make sure. So plus, this is another skill you're going to need on the test as well, which is finding your maximums and minimums. So let's find this relative maximum. So it's actually not. Okay, so this is at -1.12. I'm just going to write that there, -1.12. And then let's go ahead and get this minimum. So good thing I checked because would have had the wrong values there. Left, right, guess. And 1.79. Okay. So I'm just writing down the x values because that's all I care about for the intervals. Obviously, they have a y value. Like there is a value this reaches and a value that reaches, but I don't need them for this specific problem. Okay, so when is this graph increasing? It starts off increasing. So that's from -infinity to this number, the -1.12. And then it decreases. So let's go ahead and just write that interval while we're at it. It's going to be this number to this number. So the two weird decimals we just found, 1.78. And then from 1.78 on forever, it increases. So 1.78 to infinity. Perfect. So a really good problem for this test, but also even just the exam, reviewing increasing intervals with polynomial functions. Nice kind of tie together of a lot of things. Okay. Find the solutions here. If it's find the solutions, I always like to try factoring because right here, I see a GCF right away. So, oops, I don't know, I'm right in there, but x can come out of everything. Leave me with x squared plus 3x minus 28, which I think we have factors of -28 that could add to 3. We could use a 7 and a -4. Yep, that would work. So x plus 7, x minus 4. And at this point, I know my solutions because those solutions, again, are just the zeros of the function. You know, what makes this equal 0? So those solutions would be 0, -7, and 4. Boom, boom, boom. You could also find them by graphing. You know, there's absolutely nothing wrong with graphing, but factoring is kind of generally considered sort of the best starting skill because graphing isn't going to always give you everything you want. But in this case, since they are all whole numbers, we will just see this graph crosses at -7, 0, 4. So easy check to make sure you're right. All right, so that one's not that bad. Last one, find all the real and complex solutions. This is kind of the most intensive problem. So it's the same concept as the previous one, except you're going to notice that it's going to end up having some complex or imaginary solutions. So first off, we got a number over here. I want to add that over. So our real function that we're working with is this. So it's going to be plus 28. Now, I like to start with factoring, but this one doesn't have any kind of GCF. So I really have to start this one by graphing. So I get that entered, and I'm going to be looking for any real solutions. If I'm lucky, the problem has 3 real solutions, and I just find them, and I'm done. Because remember, if it's a cubic, it's going to have 3 solutions. If it's 4th power, it's going to have 4. If it's 10th power, it's going to have 10, so on and so forth. So I need to find all 3 solutions. So I graph this, and I see what I'm working with. And unfortunately, it looks like it just has 1 real solution because the other loop's up here. So in that case, I think it's at -4. Let's check. Yes, it is. So -4 is one of my solutions. So as I'm coming up with these solutions, I'm just going to write them up here, I think. So -4 is one of my solutions. Now what I can do with that is I can take that -4 and I can divide it out of here. Or sorry, divide it out of here to figure out what I'm left with. What's the remaining quadratic that I can then, I'm going to probably have to do quadratic formula with. So we've got 1, -1, -13, and 28. And we're going to do our synthetic division. So we drop the first number down, we multiply, we add. We multiply, we add, we multiply, and we add. We should always get remainder of 0. And now this is the quadratic of x squared minus 5x plus 7. If you notice, that's not going to factor. There's no factors of 7 that'll ever add to negative 5. So that tells us we got to go to the good old quadratic formula. So I'm going to do it over here. Okay, quadratic formula. Opposite of b, plus or minus b squared minus 4ac all over 2a. All right. So we're going to simplify this out. And it looks like we're going to get imaginary value, which is what we kind of expect going into this. So we're going to have 25 minus 28, which is going to be just negative 3. So this is a pretty easy to simplify root because 3 is a prime, like there's no perfect squares that go into it. So we can just bring the negative out as an I. So our solution is going to be this, 5 plus or minus I root 3 over 2. And so that I would just write up here where I was listing my solutions, I would just put that as my other 2 solutions. And you can write it like this with the plus and the minus, or you could write them separately. You could say 5 plus I root 3 over 2 and then comma 5 minus I root 3 over 2. Both are the same thing. So just keep that in mind. So there we go. So at this point, I know I'm done because I did find all 3 solutions because I know it's going to have 3 because it's a cubic. All right. So hopefully that's pretty helpful for you. Like I said, those are kind of the 5 most missed problems from previous tests and definitely worth knowing for this test.